a systems of equations. What is a system of equations? What does that mean? Oh boy. If I say you have a system of equations, that means you have two lines or equations. Right? Like just a regular one linear equation is just a straight line by itself. When I talk about a system of equations, I'm talking about two lines. Technically, it could be even more than that. It could be 3, 4, 5, it could be whatever. But we'll just say two lines because that's all we ever deal with. Okay? So a system of equations is two lines at the same time. What does it mean to solve a system of equations?
You graph the points.
Yeah, you graph them and you find out the x and y. Yeah, the y, the x. So we did one and then the other. And these x and y values were important to us because it's the coordinates where they cross, right? And you're all right. Like, so it's the coordinates where they cross, it's the y value where they cross, it's the x value where they cross. Those all are right. But when I say to solve a system of equations, that's what you're doing. You're figuring out where two lines are crossing each other. Ideally, you'd have a picture. And if you have a picture, it's super easy, right? You can just look at it and be like, oh, they cross right there, and point to it. Realistically, we don't have pictures very often. Instead, we have equations, and they're written out for us. We learned something called substitution yesterday, and that is our method to solving a system of equations. I'll do one with you, and then you can do one on your own. I'm going to do the second one with you because it's actually a little bit harder than the first one because there's decimals. The first step to substitution was to understand that when it says this y equals 0.5 minus 4, that this y right here also equals that same thing. So what we were doing was we were substituting this information into the second equation. We took these values and we put them into this equation. It's called substitution. So I now had 0.5x minus 4 equals 2.5x plus 14. And you see how I've taken this equation and I've turned it into that by substituting. Remember that from yesterday?
Why not?
Beautiful. Once you've done that, you should only have one letter left. If you look, the only letter I have is X. I mean, I have two of them, but all the Y's are gone. That's because I substituted properly. Now your goal was to get the X's to be on the same side of the equal sign. So I'm going to take this 0.5x and I'm going to move it to the other side of the equal sign. You do that by using addition or subtraction. In this case, I'm going to subtract 0.5x. And I'm going to do it from both sides. The reason I choose subtraction is because 0.5 minus 0.5 will get rid of those x's on the one side. And it'll move them to the other side. I now would have negative 4 on the left equals 2.5 minus 0.5 would be 2x. The plus 14 would still just be plus 14. First job, get all the x's on one side. I've done that. They're all on this side of the equal sign now. Once you have them all on one side, your goal is to now move the numbers away from the x so that the x is all by itself. It's called isolating it. The two numbers that have to move to the other side is this 2 and this 14. You have to move them in the proper order. So the one that moves first is determined by reverse BEDMAS. So you do BEDMAS but backwards. So in this case, if we think about BEDMAS, the opposite backwards means that we would have to move any additions or subtractions first. So this plus 14, it needs to move first. How can I move plus 14 from one side to the other? Minus 14, right? I call it opposite operations. So the way you move something is by doing the opposite of it. If it's currently plus 14, I would subtract 14. And what you do to one side, you do to the other side. Those 14s will cancel out. On the left-hand side, negative 4 minus 14 would equal negative 18. And on the right-hand side, I would still have 2x. Perfect. The next number I need to move is the 2. The way I move that 2 depends on how the 2 and the x are connected. This is 2 times x. The opposite of timesing is dividing. So I need to divide both sides by 2. When you do that, 18 divided by 2 is negative 9. On the right-hand side, 2 divided by 2 would go away. I now have negative 9 equals x. Perfect. That is half your answer. It's only the x value. You need an x and a y value. You need the coordinates, right? So to find your y value, you take this x value and you substitute it into the original question. 2, when you take your x value and you put it back into that original equation, you should have got this. Y equals 0.5. Instead of x, you're putting times negative 9. And then minus 4. I kind of squished it over there. I apologize. This, you just calculate. So in your little calculator, you're going 0.5 times negative 9, which would be negative 4.5. And then subtract 4. So negative 4.5 minus 4, we should have got y equals negative 8.5. You now have an x value and a y value, so you now know where these two lines cross each other. They cross each other at negative 9, comma, negative 8.5. Remember, you answer as a coordinate, where the x value goes first, the y value goes second. Cool. The first one, I've asked you to try the substitution to start it off. There's some good, one of the hard things about this is you could do it a little different and get the same answer. So, for instance, Kai might be doing it one way and Evan might be doing it another way, and they both get the right answer. Because when I say things like substitute this equation into this spot, I could also substitute this equation into this spot. All right, it still would work because I'm still changing y to be something else that it equals. That's still fine. It's just a different route, right? So you could get the same answer by doing something slightly different. For us, on this question, I'm going to choose to take this 5x plus 10, and I'm going to substitute it in for that y value. Either way, you should have an equation where one side says 5x plus 10 and the other side says x plus 22. You might be on opposite sides, and that's okay. But everybody should have had this on one side, this on another side when you were done. Cool. After substituting, what is the next thing I need to do? Yes, I need to move my x from one side to the other. And again, this is one of those things that you could do one way or a different way and still get the right answer. So Bree's suggestion was we take this 5x, we subtract it to the other side, which would work. You could also take this 1x and subtract it to the other side, and that would work too. Right? As long as you're moving the x's to one side or the other, you're going to be good. And remember that this is a 1x. It's an invisible 1. Okay, some things I want to talk about that I didn't really stress yesterday. When you're doing systems of equations and this much algebra, one of the biggest things you must do is organize your work. If you're not organized, it's very likely you're going to make a mistake. So you will notice that I will always follow the same pattern. I do something to the equation, I show what that something is, and then I rewrite my equation. I never do more than one thing at a time. So in this question here, I subtracted 0.5x, and I showed that I subtracted 0.5x. And then I rewrote my equation. Then I did something else. I moved my 14 and I showed it. Then I rewrote my equation. Then I did something else. I moved the 2 by dividing, I showed it, and then I rewrote my equation. Follow that routine. Do something, show what that something is, rewrite your answer. If you get caught in that sequence of like, oh, I'm going to do 3 things at once, it's a pretty good chance you're going to mess up somewhere. So do something, write it out. Do something, rewrite it out, and keep doing that. It'll help. The second piece of advice is work vertically. So try not to go left to right too often. Try to go straight down until you run out of room, and then start a new column if you need to. But go straight down. I had a math teacher. He was like the best math teacher I ever had. And if you didn't work vertically, he gave you 0 on the question, even if you got it right. So if you worked left to right, 0. You had to follow his organization system, which as a student, I used to always argue with him and be like, well, it doesn't matter. And then when I started getting to really hard math questions, I understood why it mattered so much. Because he was building good habits of organization. And then when you get to grade 11 or grade 12 and you're using like a ton of space for your work, you keep it organized. Left to right will not be organized. Up and down will be. So try to create good habits like that. Okay, over here, let's try it. We're going to move this 1x over. To move something, I am doing subtraction of that 1x. You said move the 5x, that's the same too. I'm choosing to move the 1 because it'll keep my x's positive. You'll get negative 4x, I'll get positive 4x. So that's slightly different. Yeah.
Okay, so if you were to move the 5x to do the same thing.
Yeah. Did you do that? Did you move? Actually, yesterday we always moved left to right, didn't we? So let's do that. If that's what most people are doing, because I think so, let's do that. Like that? Okay, so we're going to subtract the 5x. I'm now going to rewrite out what I have. These 5x's would cancel, so I have 10 equals negative 4x plus 22. I did something, I rewrote my work. Now let's do something again. What do I have to move first? Yeah. Yes, I'm moving the 22 first because I move additions and subtractions first. And you do it by doing the opposite. The opposite of addition is subtraction. So you're going to subtract 22 from both sides. That gives me negative 12 equals negative 4x. I did something in blue. I rewrote my equation now in black. What number do I have to move next? I'll give someone else a shot at it. Yeah, Sean. Yep. What number? Yeah. I got to move this negative 4 to the other side. And it's division, not addition. The reason why is because this is negative 4 times x. And the opposite of timesing is dividing. So he's spot on. We are going to divide both sides by negative 4. And then I'm going to rewrite what I have. 12 divided by negative 12 divided by negative 4 is positive 3 equals x. That is your first half of your solution. You then take that answer and you use it in one of your original equations to find the other letter. So now I'm going to have y equals 5 instead of x. I now know x equals 3 plus 10. If I put that in my calculator, 5 times 3 is 15, plus 10 is 25. Giving me an answer of 3, 25. Yes, sir. Yes, sir. That's substitution.
I'm scared.
Yeah, you missed yesterday.
Why do we learn two ways?
Good luck.
Pardon?
Why do we learn two ways to do it and not just do it one way?
There will be there's actually 3 ways to do it. So in 10C prep, you're going to learn a 3rd way to do it. It'll be graphing it. But the reason why is because some ways are easier depending on the question. So these questions are nicely built for substitution questions. But the next questions we look at, for instance, let's scroll down and look at one. This question is not set up nicely for substitution. The reason it's not nice for substitution is I don't know what x equals in either of those, and I don't know what y equals. So I don't know what to substitute, right? In the other questions, it always said y equals this. So I could move it and substitute it really easy. I don't know what y equals here, and I don't know what y equals here. So that's why they have more than one way. Technically, if you got really good at one way and you had very strong algebra skills, you could always use that one way. Ideally, you recognize which one's easier to use and you use the easier one. Ideally. Okay, let's move on to our second method. People usually like this one a little bit more. I like substitution. People usually choose elimination. Of course. Okay, number 1. The first thing you want to make sure of with elimination, you guys need to stop chatting so much. Thank you. The first thing you need to notice for elimination is you have to have things in the same order. So for instance, what I mean is in equation 1, notice how it goes x, then the y's, then the equal sign, and then the 14. My second equation needs to go in the same order. And if you look, it does go in the same order. It goes x's, y's, equal sign, and then a constant. Hey, David, this will work better. The order has to be the same. If the order is not the same, it makes it a nightmare. Perfect. The second thing you need, so first was order the same. Second is make one of the letters have the same coefficient. So if you look, my y's, this one is 5y, this one is 3y. They're not the same. But if you look at the x's, this one is 4x, this one is 4x. They are the same. That's good. So we've got same order and same coefficient. Thank you. Cool. Once you have that set up, what you want to do is you want to take one of the equations and write it underneath the other equation. So I'm going to take that second one and I'm going to write it underneath the first one. Like that. So I took the second equation and I wrote it under the first equation so that they're stacked on top of each other. Now, what I'm going to do is I'm going to add or subtract these two equations together. And I'm going to add or subtract based on whatever will eliminate one of my letters. So for instance, if I chose to add, don't write this down because it's wrong. So if I chose to add these two equations, 4x plus 4x would be 8x. 5y plus 3y would be plus 8y. And you'll notice that I still have both letters. Neither one got eliminated. So adding is wrong here. But what happens if we subtract these equations from each other? Well, if you go 4x minus 4x, you end up with 0 x's, which means they eliminate each other and the x's will be gone. I then have 5y minus 3y. 5 minus 3 is 2y. People usually put 7y, they usually put 8y because they see 5 plus 3. But it's 5 minus positive 3. So make sure you're subtracting everything. The equal sign, it stays in the exact same spot. So it's still right here. You then go 14 minus 10 is 4. And if you've done this properly, you now have an equation with only one letter. Yes, sir.
I know what y is.
What's y equal?
2.
Yeah. And so this is just like substitution now at this point, right? You got to get y by itself. And to get y by itself, you're going to divide both sides by 2. If I divide both sides by 2, I get y equals 2. The beautiful part about elimination is that after you eliminate, it's usually pretty easy to find one of the letters. The hard part about elimination is finding the second letter. So you're going to do the same thing you did for substitution. You're going to take your y value and you're going to put it into one of the original equations. So that you have this. 4x plus 3 times 2 equals 10.
Could you put it in the first equation?
You could, and it would get you the same answer. Yeah. So you would have 4x plus 5 times 2 equals 14. Yep. Yep. Now before, it was nice and isolated, and you just had to calculate it. But now it's not going to work so nicely. So you're going to have to do a little bit of math here. The first thing I'm going to do is I'm going to calculate what 3 times 2 is. So this will become 4x plus 6 equals 10. And now I have one letter on one side, so I need to start moving things away from it to solve for x. Which number am I going to have to move first? Somebody do. Yeah, hit me up. The 6 will have to move first. And because it's plus 6, I'm going to subtract 6. This leaves me with 4x equals 4.
I already know what this one is.
Yeah.
Just looking at it, I saw
If you can do it in your head without doing the steps and stuff, are you allowed to do
Yep. You definitely are. I would recommend that you still practice writing down the steps. Because it'll get to the point where you won't be able to like do it in your head, and so you have that like foundational skill.
Yeah.
But if you can see it, like at this point, some people could just look at it and know that x equals something. You could do that, and I'm fine with that guy. What number am I going to have to move now to get x by itself? Yeah, I was going to say Julian.
4x.
yeah, you're going to have to move that 4. Sorry, Matthew. I'm calling you by your last name. You have to move this 4 away from the x by dividing it to the other side. That gives me x equals 1. Meaning my answer is 1, 2. That's elimination. Let's try another one. So we got number 2. We'll do 2 more together, and then you'll do a few on your own. The setup for elimination is key. Okay, so you have to have it set up nicely. Everything needs to be in the same order, and then you need one of the coefficients to be the same. If you look, this is the same order. They both have x first. They both have y second. Then they have their equal sign, and then they have a constant. It must follow that order. Perfect. Now you need to make sure one of the coefficients is the same. If you look at the y's are the same. That's good. The x's are different this time. That's okay. You only need one to be the same. If you have it set up properly, you then can write one underneath the other one. So I'm going to write the second equation underneath the first equation. Yes, sir. Yes, sir. Setup is very important for elimination. Once they're one on top of each other, you need to decide whether you want to add or subtract. Last time we subtracted. This time we're actually going to add. The reason why we're going to add is because this is a negative 20 and this is a positive 20. And if you add negative 20 with positive 20, it will equal 0. If you had subtracted, negative 20 minus 20 would have become negative 40, which would not eliminate. So make sure you're choosing the right operation. This one is an addition question. 15 plus 16 is 31x. Negative 20 plus 20 will eliminate. 33 plus 60 is 93. So I now have a new equation of 31x equals 93. I've eliminated properly because my one letter of y is gone. All I have left is x. Cool. Now what? Yeah, hey. Yeah, move that 31 to the other side. So to move that 31, I'm dividing by 31. That means x equals 3. Once you have one of the numbers, you can find the other one by substituting it into one of the equations. That gives me 16 times 3 plus 20y equals 60. If you did another equation, that's fine. After you make the substitution, there's a multiplication that has to happen. 16 times 3 is 48. So 48 plus 20y equals 60. Now what? Kenzie, what do you want to move first?
I'm thinking subtract 48.
Yes, move the 48 first. Because this is a positive 48 being added to my y's, and we move addition or subtraction first. We need to subtract that 48 from both sides. Which gives me
12.
20y equals 12. Now, I need to move that 20. To move that 20, I would divide both sides by 20. You put that in your calculator, and I believe you get 0.6. Meaning my answer is 3, 0.6.
Y.
Yeah, I wrote X for sure. I fixed it in my coordinate. That's elimination. Your algebra skills are already getting better, right? Like, you're following along a lot better, I can already tell. Algebra skills is like this, moving numbers around. You can already see it's like coming along. All right, number 3. Number 3 is a little harder. The reason why number 3 is a little harder, number 5. The reason number 5 is a little harder is because it's not set up properly. Yeah, so we need to move it or change it somehow to set it up properly. The setup is same order. These are in the same order. X, Y equals constant. X, Y equals constant. Order is the same. But the second thing that you have to have is you have to have the same coefficients. 3x and 9x are different. 4y and 6y are different. So if you don't have the same coefficients, you need to make them the same. And you make them the same through multiplication. So looking at your numbers, is it possible for me to multiply 4 to become 6? No.
Yeah.
But could I multiply 3 to become 9?
Yes.
Yes. So what do I need to do to this first equation so my x's will match?
Times by 3.
Bingo. Multiply everything by 3. And when you multiply everything by 3, you get a new equation, which will be 9x plus 12y equals 90. And now my equations match, and they have a coefficient the same. If you don't have both those things, you can't do elimination. Now that they match up good, write one above the other. So I'm going to write the other one underneath here. And I decide whether I want to add or subtract these two together. Anyone have a feeling on which one we should do?
Subtract.
Why subtract?
Because 9x, if you subtract it, it gets rid of it.
9x minus 9x equals 0. Perfect. If you added it, it would have become 18, which wouldn't have eliminated it. So we're subtracting these questions. Now, the subtraction's hard on this one. The 9x minus 9x, that's not hard. But the next one is. This is 12 minus negative 6. That's a double negative, which means it's actually 12 plus 6, which would be 18y. Same with the constants. It's 20 or it's 90 minus -9. 90 minus -9 is like 90 plus 9, so it's 99.
I know what y equals.
How'd you figure it out first?
So we have 18y
Yep.
equals 99.
Yes?
You divide 18 by 18.
Yes.
99 by 18.
Exactly. So he's going to divide both sides by 18, and then what do you get, Ken's?
5.5.
Perfect. Actually, I want to write that in black. So I'm dividing the 18 from both sides. I'm left with y equals 5.5. Once you have one answer, you substitute that in to the second equation. Whoa, sorry. And you try to calculate your other value. What is going on? There we go. So I now have 9x minus 6 times 5.5 equals -9, like that. The first thing you're going to do is you're going to multiply that 6 times that 5.5. So I have 9x minus
33.
33.
Yeah, that's what I got.
Perfect. Right? I multiplied 6 times 5.5. I now can solve for x. I'm going to move the 33 over by adding 33 to both sides. I have 9x equals 42. I then divide both sides by 9. Oh, sorry, -9.
Yeah, that would be 24.
Yeah, it's very different. Good save.
Is 2.6. Well, 2 2/3. 2 2/3.
2.6 repeated?
Yes.
Okay, I'm going to put 2.6 with a little line over it. Yes. Yes, sir. Now that you know your x and your y, you can answer it. The answer is 2.6 repeated, comma 5.5. That is where those two equations would cross each other if you put them on a graph. Yeah, if it was a test, it would probably say round, and you put 2.7. In fact, if you put 2.6, I'd give you the right answer. If you put 2.67, I'd give you the right answer. If you put 2.6 repeated, I'll give you the right answer. If you put 2.7, I'll give you the answer. I'll be pretty lenient on that stuff. As much as we should be good at rounding, we haven't really spent a lot of time on it as a group, so I'm not going to punish you for that. All right. I want you guys to go back here and try number, actually, I lied. Let's do number 6 first. 6 is easier than the next one, so let's do 6. I'll give you a shot. Try it completely on your own, and then I'll show you the answer. So you would write one equation above the other. Can you read that? People in the back? You can tell me honestly if you can't see that, because I'll just reconnect different way. Yeah? Okay, I'll try to do it from over here. I'm just not going to move my stand. We're going to subtract these two equations, because 1y minus 1y will cancel out to give me 0. So I have 0 equals 5x minus 1x is 4x. 5 minus 9 is negative 4. And now I've sufficiently eliminated one of my letters. Perfect. Now what? Shane, yeah.
I did the substitution.
Yeah, and that's fine. If you did substitution, you'll get the same answer. You should at least. Those of us who did elimination, what would be my next step here?
Your next step would be to take 4 and divide it into the 4.
That actually will work.
Yeah, it comes out as one.
Yeah, it'll still work. I'm going to do something different, but you are right. That would work. As long as you understand you divided 0 by 4, which is still 0. You have to divide everything by 4.
Oh,
Just so you know, but it works out even if you forget to. Cut. Add 4. Right? Move this 4 to the other side. And when you add 4 to the other side, you now have 4 equals 4x. Now what? Nothing. Divide both sides by 4. When I divide both sides by 4, I get 1 equals x, which is the first half of your answer. Remember, you use that in my next equation to solve for y. That means y equals 1 plus 9, which is 10. So your answer should have been 1, comma 10. And you could have done that. Honestly, there's multiple different strategies, right? I'll show you what I think is the quickest way through a question. Maybe not always the way you view it, though. So it is okay to have a little bit of like confidence in like, what if I do this? Like, believe in yourself a little bit. When you practice them enough, you'll do the right thing. All right, now we're going to scroll back up. We'll talk about how to start number 3, and I'll let you go on your own. So, is it set up for elimination? It's in the right order, right? X, Y equals a constant.
Not the same coefficient.
Not the same coefficient. If I look at my x's, I have 2x and 4x. If I look at my y's, I have 3y and 5y. I need to make one of them the same. Perfect suggestion. Multiply the first one by 2. If I multiply this thing by 2, 2 times 2 will become 4. Now my coefficients on the x's are the same. Remember that when you multiply something, it's everything in that equation. You can't just do 2 or 3. You have to do all of them. So I'm going to multiply everything by 2 to give me a new equation of 4x plus 6y equals 10. Now, I want you to try to solve that problem using elimination. Write these one on top of the other, and I would subtract these two equations from each other. The reason I'm choosing subtraction is because 4x minus 4x will equal 0. It'll eliminate the x's, leaving me with 1y equals negative 5. Right? 6 minus 5 is 1. 10 minus 15 is negative 5. I will leave you at that spot to see if you can finish it off. At negative 5, and you put that negative 5 into this equation right here. You would have had 4x plus 5 times negative 5 equals 15. Remember that after you substitute, you're going to multiply that 5 and that negative 5 to become negative 25. After you substitute, we almost always have to multiply. That's why we substitute with brackets, right? So make sure you do that multiplication. And then we do our algebra. We move something, we rewrite. We move something, we rewrite. All the way until we're left with just our letter. The first number to move will be negative 25. I'm going to add 25 to the other side, and I'll rewrite my equation. So I'm going to add 25 to give me 4x equals 40. Then I need to move the 4 by dividing to give me x equals 10. Giving me a final answer of 10, comma, negative 5. Perfect. We'll do number 4 together. I want you to try to set it up right now because there's something that needs to be done to set it up. So I'll let you all try to set it up on your own, and then I'll do it with you. I'm only going to do like the opening spot for you. So when I look at my x's, which I'd never recommend looking at your x's, right? Once it's over, just move past them. And then I got like one chunk. Oh, come on, give me a little something. If you look at your x variables, Nick always comes in late with that. I like it. The sarcastic laugh, at least it's something. If you look at your x variables, I'm never going to multiply 3 to become 5. Not by any numbers I know. So I'm not even going to try to manipulate the x's. I'm going to look at the y's, and I'm going to realize 4y could become 8y pretty easy. I multiplied this side by 2, and now my y's will match up. So I'm going to go ahead, and I'm going to multiply all this by 2. Giving me 6x minus 8y equals 20. Now I'm set up properly. Same order, same coefficients. I'll give you a minute. So I've taken my first equation and I've written the second one underneath it so I can decide whether I want to add or subtract these equations. There's some hard parts, not hard, there's some tricky parts to this algebraic question. The tricky part here is recognizing that you're going to subtract these two equations from each other. The reason I'm going to subtract is because negative 8 plus negative 8 will actually be negative 16. I want to go negative 8 minus negative 8, which will turn it into 0. So that's kind of a tricky part of this question. Remember that a double negative will turn this into negative 8 plus 8, which would be 0. So I'm subtracting these questions from each other in order to get this double negative. So it'll be negative 8 plus 8. Leaving me with 1x equals 6. There's like moments in this question, not even this question, in algebra, that are just kind of like, they're nasty. They set up weird, they look weird, and it's very easy to make errors. This is extremely easy to make errors. Most people would add those things together. And I think just the feeling of like negative should be 0 for some reason, or you're going to view it as 8 minus 8. This is negative 8 minus negative 8. The double minus becomes a positive to cancel out. That's kind of like gross. Yes, sir. Yeah. Now that you know that x equals 6, you can try to finish it off. It's up there on the board. So if you want to see if you did it right, one of the tricky parts of this one is after you substitute the 6 in, you get this situation, which looks like you need to add 30 because it's that subtract 8y. But reality is that this is a plus 30 minus 8y. The 30 is positive, you need to subtract it to the other side. Last step would be divide by negative 8 to get 2. I just handed you out your homework. You do have a quiz tomorrow. That quiz will be on everything we've done in January. So at-home learning and here learning. So that means we're talking about slopes, y-intercepts, creating lines. All those lessons are posted online with the practice and answers. So if you need to look back, and that's fine. We will then review that quiz after we do it. So like the next day. Wonderful. Take care of yourselves. Wait for the bell in about 1 minute.